So this is the part 1 of ancient Sri Lankan reservoir construction webcast series. In the introduction, I discussed various parts of a small size reservoir, like a village reservoir, the BUND, the spillways, and etc. Now we are going into large reservoirs. So what is a large reservoir? Large reservoir would be like something like Minneri Wewa or Minneri Reservoir that has a circumference of 40 miles and total area, the surface area, is 5,000 acres or 7 square miles. That is the surface area of the reservoir when you look from the top, and there will be 5,000 acres. Now 1 acre is about 20 tennis courts approximately. So now you could imagine how big, how large this reservoir was. So basically, and the height of the BUND in some places could rise up to 75 feet. That would be the water column, 75 feet, when the water rises up all the way to the top. And that is like a 7-story building. That's a lot of water pressure. And the length of the man-made BUND is 5 miles in Minneri. And other reservoirs also kind of similar. The Kaudulla, these are all kind of similar size. Padavir, maybe a little smaller. Kaudulla, Kanthalai, these are kind of similar size reservoirs. So these are large reservoirs. So now we are going to look into how these reservoirs get water. So normally these reservoirs gets water from the hill country, and the water flows down from the hill areas. In the case of Kaudulla, it gets water from the Knuckles Mountains. The water comes down, and then that water would go into rivers and streams, and they built ANICUTS. In Sinhalese they call Amuno. And then they built canals, which we are going to talk about. Some of them, like the Elena Canal, was 54 miles, and they're long canals. And these canals had sluice. I didn't show here sluice to give it to paddy fields around here. It's just not only take water to a reservoir. On its way, they would take out water and give it to paddy fields on its way. So you get water from these constantly flowing rivers and streams, and also you get rainwater. And the water is going to flow towards the low ground, and they build a BUND here. That's the BUND that we were talking about. And there's a sluice to take water out for paddy fields, and then a spillway to get rid of excess water. Under no circumstance, water should go over the BUND. BUND is made of soil, sand, clay, etc. You never want water to go over the BUND. Once the water goes over the BUND, that BUND going to breach, and all the water going to go, and disaster could happen. People in these villages could drown, and it has happened. So all the water should go through the spillway. Spillways are made of rock. Now, here, Padavir Reservoir, most gigantic works of all the reservoirs. 30 foot broad at the summit, that will be the BUND. 180 feet at the base, 70 feet high. Its construction must have occupied 1 million people for 10 to 15 years. So there will be this BUND that they built, so 180 feet, depends on the reservoir. but generally this is something representative. So 180 feet is, if you think of a 100 meters, 100 meter dash, so that's 300 feet approximately. So this is more than half of 100 meter dash, and then this is 30 feet. So this is a lot of earthwork, and this stretches for 5-6 miles. Minneri 6 miles, Kaudulla 5 miles. So this amount of earthwork, this is 7-story building, height of a 7-story building. So you could see amount of work involved. And according to Henry Ward, Padavia Reservoir would take million people at least 10 to 15 years. And then the Kaudulla, I have information here. It's 6,400 acres. The BUND is 6 miles. Height of BUND is 50 feet. And this is a photograph of a BUND, reservoir BUND. The water is pressing the BUND this way. And this is another one. And this one is curving outside, and that's not really a good design, curving out. So it should be curved inside, so the pressure would get stretched out to the side and you could get the arching effect on this. But the location, of the BUND is determined by the terrain. You have to go with the terrain. Sometimes you cannot do exactly what you want to do. And now we come to the spillway. Spill is where the water would flow out, excess water, before it goes over the BUND. You never want water to go over the BUND. Now regarding the Kaudulla spill, from R.L. Breuer, he said that the ancient spill, PITAWANA of Kaudulla, is measured to be 216 feet in width, 170 feet in length. Huge spillway made of rock. For comparison, the width of a spill is more than 3/4 length of a soccer field. That's just the width. The spill was built using hammered granite, a solid structure one could imagine. Each block of granite is shaped precisely to fit its neighbor. The whole structure eventually acts like one huge rock. The embankment of Kaudulla is 60 to 80 feet high, with a base of more than 200 feet and a length of 3 miles. When George Towner, first to translate Malwahu to English, visited the site, he was unable to understand why such a huge spill was built. Turner wrote, "One of the most stupendous monuments of misapplied labor in the island." So he thought that the spillway was useless to build such a huge spillway. You really don't need this one. But he was wrong, and I could show you that how Kaudulla could spill out. And, so this is a YouTube video by someone named UIUX Ted, and you could see how violently this Kaudulla spill could spilling. So here let's look at here, and then here you could see they put a this is the normal spillway, and on the side they had a new spillway. The both are new, but you don't see the rock spill that they had in the past built by King Datusena. But they added another spill. Let me try this. Okay, see here, this is a spill with a gate, and I will be able to show better pictures. The way you could see the water is going over the bridge. So this is how violent the water at Kaudulla could get. So ancient engineers had a huge spillway because of this reason. So that's what the spill does. Just imagine that water column were to go over the BUND. The BUND would be gone in minutes. And this is I could not. We don't have the ancient spillway of Kaudulla anymore. It was replaced. But from the description, it could have looked like this. But this is not a spillway. This is a Anicut. But it's the same thing in the sense, a structure that allows water to go over it. Now you cannot have water going over a BUND, but spillway is designed for a structure for the water to go over it. And this is an Anicut in Malwahu, and we'll talk about this Anicut later, that this water goes to a Yodha well. But anyway, this was made of hammered granite. You see granite blocks here. There's another photo, I think. I would have another photos later. So anyway, this how it would look like, the spillway of Kaudulla, but much bigger. So the water would go over this. And there's something interesting about the Wewa spill. And here Henry Parker says the ancient BISOKOTUWA, which we are going to talk about later, is situated 2,000 feet east of the spill. And it talks about the BISOKOTUWA. And then he says a 1,000 foot long solid rock outcrop on the western side has been used as the spillway. The tank has been designed in such a way that the rock bed lied approximately at the full supply height of the tank. So what they did was they looked at the rock and they said, why do we want to build a spillway? Let's use this big rock. The building a spillway takes time and a lot of labor. So the engineer said there was a 1,000 foot long solid rock. Why not use that as spillway? And now the problem is that you cannot, the BUND has to be lower than the spillway. The BUND has to be higher than the spillway. Not spillway should be lower. But BUND cannot be too high, because then you lose the purpose. You lose a lot of water. So BUND has to be 2-3 feet high than the spillway. And your capacity of the reservoir is determined by the height of the rock outcrop. But anyway, they figured that would be a good idea to use a solid rock outcrop as a spillway. But unfortunately, I could not find any photographs of that. Now, I want to discuss Kaudulla, as I found this has more information. And so Kaudulla is located here, south of Anuradhapura, and we are going to take a look at Google Maps here. And now here we have Kaudulla is the red dot, and here's the Knuckles Mountains, and these green areas are wetlands, wet area. So there are so many streams going towards Kaudulla, little streams, and this is the catchment. That's called the catchment basin of Kaudulla. And now you could see Kaudulla over here, and let's go to a bigger one. Now here it is. Now this is Kaudulla, and water comes from these sides, the wetlands, and this is the BUND. This is the BUND that you have. This is the BUND. That's the man-made bund here. So the water comes from this way, and probably some water from that way too. But the mountains, the high ground is on here. So the water coming here, and this is low ground here, and low ground you could see the paddy fields, and the bund was built here to hold the water. All the water coming from these sides is held up here. Normally there could have been some streams, natural streams, and sometimes that's not enough. Natural streams are not enough. In the case of Kalawa, they brought some canals also, artificial canals to feed this huge reservoir. How many acres? 5,000 acres is the surface area of the water body. Now we go to a bigger picture here, and now you could see the bund little clear, and this is the spillway that we talked about. And you could see they have built some wahhabis mosques around here. Bund 1, 2, 3, 4, 5. I don't know why they're doing that. And now we go to a bigger picture, and this is the spillway. This is the spillway, and this is another spill that they added because this was not enough. The whole idea is you have to get rid of the excess water quickly before that water goes over the bund. If that water goes over the bund, this bund is going to fail, and all this water is going to go through it. Once it fails, there's no stopping. How are you going to stop? There's no way to stop. Just keep going until the whole reservoir is released. Just imagine that, all that water going through the bund. Once it starts, you cannot stop it. So you don't want water going over the bund. So for that reason, it looks like they built another one. This is the initial spillway built by the Britishers. The original spillway is gone, totally destroyed. Can't see anywhere. One that made of rock. It's unfortunate why they did not at least take some of the old ones and have like a replica on the side. They could have done that, but probably they didn't think that. So let's go to the next photograph. So this is the spillway. This is the concrete spillway, and when it is spilling, and the video you saw that it could spill, this whole area could go under, including the bridge over there. And this is the Jayaganga, or also known as Yodha. That's somewhere in here. Somewhere in here. They took the water from here, from Kalawa. King Dhatusena built this Jayaganga and then took that water all the way to Anuradhapura city, Anuradhapura town. And because the reservoirs in Anuradhapura town, Tissavawa, Abhayavawa and Nuvaravawa are small. They dry up. So Kalawa is huge. So they took the water from here to the Anuradhapura town, and because that's where most people lived. Now there was a problem. The height difference, this is kind of flat land. Height difference between Anuradhapura and here was not much. It was like they have to go 6 inches per mile, and such a low gradient, and they have to maintain that. And the question has been asked, how did they do it with the equipment they had? If an engineer were to, or a surveyor were to told, maintain that gradient, it's going to be very difficult. It's going to be a very hard thing to do. So the Jayaganga is the old word. Jayaganga is the old word that is used in Mahavansa. built by King Datusena, and today they call it Yodha. There are a number of Yodha, so it's kind of confusing. There's another Yodha in Mana area, another one in near Elena Canal. So that is what it is. That's going to Anuradhapura, the Kalaba of water going to Anuradhapura city. And now here in this Google photograph, so here's your BUND here, and then here is your wetlands. Here's your wetland. It could get filled up. Estuary. Actually, estuary is not a correct term, but I would say wetlands is the correct term. And I want to show you my drone footage here. Let me get this drone footage. And now here you could see this is the BUND we saw. This is the BUND on the left hand side of the photograph. I can find it. So that's the BUND, and this is that they used rocks. These rocks are new rocks, but in the past they used cut rock. I have seen in some. Now they just throw in some rocks like that, but in the past, historically, they cut the rock and they fitted in one by one together. That's today it's cheap work, cheap stuff that doing. They just bring it in a bunch of rock and throw it in there. And I will find a photograph that I saw in embankment. They cut this rock like squares and then they fitted in. And that's the way it could have done in the past. I don't know. We might be able to find in those rocks in the bottom of the Kaudulla. So let's see here. And so this is the spillway that we saw. And that's the water coming in from this area. So, and I want to look at another reservoir, just to little different. That will be the Kanthalai reservoir. Another videotape, YouTube video, and this is the Kanthalai SLUICE. And this is King Agabodhi who built Kanthalai. Okay, here's the BUND again, Kanthalai BUND. So the water is coming here. Now here you could see this is low ground here. This is where you have your paddy fields. And this is the water body. If you don't have this BUND, the water is just going to go down there. So these are man-made BUND. And if you could see here, it's like 50-60 feet. It's low ground to the top of. This is the original ground, and probably the ground in under the reservoir could be lower than here. So you could imagine how big this BUND was. And you have to build this, you have to bring in soil. Normally you bring it from here and put it in here. And there's a lot of work involved here. And then once this is high ground here, this is low ground, this is high ground. So the water comes like that and gets stuck here. And let's see what this. So this is the BUND again. And that is King Agabodhi 1. And that's the wetlands here. This is the old sluice gate that they preserved it. And they should have done with the Kalava spill, at least portion of it, but they didn't think about that. And so And now we just talked about the spill and the BUND, and let's look at the ANICUT. ANICUTs. These are interesting. The ANICUTs are basically where you would divert water from a canal. There are a number of ANICUTs, many of them. The big ones are the Alahara Anicut, and that would feed the Alahara Canal, and that would feed Alahara Canal would feed Minneri, Kaudulla, Kanthalai, fed by the Alahara Canal. Anicut was built in Ambanganga. Ambanganga started by King Wasaba, extended by King Mahasen and others. And the Jayaganga we talked about, that was by King Dhatusena, and that takes water from Kalaweva to Tisaweva and Abeweva. So the Alahara takes water from Ambanganga to Minneri, Kaudulla, Kanthalai. So the Minneri, it goes to Minneri first, and then it goes to Kaudulla, and then finally to Kanthalai. And Jayaganga takes water from Kalaweva to Tisaweva, which is in Anuradhapura town. And then the Yodha there, which is in Mana area district, and gets water from the Malwahu through another Anicut over there, and that canal is also called Yodha. And then you have the Minipe Anicut. Has to be a big one because Mahavansa talks a lot about it, but unfortunately it's been destroyed and there are no photographs. So it's called Manimekala Dam, and it was started by King Agabodhi I and made it bigger by various other kings. So basically there are two types of Anicuts that I figure from the photographs. So when the water is coming like this, they built something like this. I will show photographs later. And then this canal was built. So the water would go through this canal. Diversion. And the other type is they build something like this. So the water comes like here. They build a dam with rock. So the water level goes up and goes like that. Sorry, here water is coming like this. So the water level goes up like that. You raise the water level, so the water could get diverted into the canal. Here you could see the water coming like that, get raised here, water level get raised, and then water would go that way. So there's the other type of Anicut. Now this Anicut is in Malwahu, and this canal would take water to Yodha. And this is what I was talking about. This is the granite. They cut it. They have a cement plaster. They had a cement plaster, some kind of a clay, and they attached them together. So this is cut granite, attach them together, and it works as one unit. So the water could go over this, which I have photographs here. See, the same one. So water could go over this to the canal. And this is the same one, I think. Nice looking. And let's go back to, so this is when it is dry. So here, so the water comes here and goes over this. Some water goes along this, on this side. And some water, when the water level is very high, the water would go over this and goes like that. And I believe they probably had another Anicut here. I don't know, I'm just guessing, to reduce the water flow because you don't want too much erosion here. So there's another one here, and I would think that would be a better design because you want to slow it down and raise the head and then diversion. So they raise the head, Anicut here, and another one here. That would be a, something that they probably thought about, but I don't know whether they did it that way. All what I see is this here. And we have evidence for this. But building an anicut across a full flowing river is not easy. Not easy even today. And King Parakrambahu said that he built a road in Mahawans. In Mahawans it says King Parakrambahu built a road across Mahanadi. Mahanadi is Mahaveligaga. What he did was there, he built a canal. Now I'm digressing. When he was building, he built a canal, according to Mahawans. So he built a canal, diverted the water like that. Let's see if the water is going like that. They diverted water. And then they built the road across Mahaveligaga. And, you know, we don't have that road anymore. That road was used to for horse carriages and things like that. So this is the Anicut that I have nice photographs. So the water would go on the side, diversion, and some of the water would go over it to the canal. And this is the type B one, that is the head on. You take it head on. And right now it's dried up, and the water would go up like above this. And then you could take the water from the side. You raise the head, take water. And this is the Hatota Anicut. It's not functional. And this is the Angamedilla Anicut. This is the Angamedilla Anicut. Now you could see a big, huge rock here. And this one is gone. This one is, Wewa has taken it. So, and in this one, in this Anicut, they have found sockets, the bedrock of the river. You know, so this big rock would sit on that like that. And isn't that amazing to go down there and make, so they should have had some kind of a snorkeling device so they can breathe and then cut the rock underneath. Or maybe they diverted this water some other way, go around, and then they constructed it. And they probably, that's what they did, because in Mahavansa it says that they diverted water in Mahaveligaga to build a road. So they probably did the same thing, and to make a socket like that. And then, as you could see, there's a big rock here, and they probably had another one here. And this is a cut rock, they cut it. This is not naturally occurring rock. And these are this is not the socket for Angamedilla, but found in another location. So you could fit a rock in the rock bed, or maybe wood, we don't know. So they cut it like that. Another one like a keyway into the rock. So this Anicut would fit in properly. There's another one here. It looks like these are like to the side. So it looks like this side is a little deeper than this side. So what does that mean? So whatever goes like that to a slant, like a battered pie kind of thing. You know, that's what it looks like. I could see depth here is more the water. And the water surface is horizontal, right? Water surface is horizontal, but this depth is higher. This depth is higher from. So there is a, I believe it probably going to the side, and you could see that here too, I guess. In the Elena Anicut, and it was done by Elena Anicut Amuna work ancient antiquity reference Arumugam 1969 has many references to ancient kings, namely King Vasabha started it, King Agabodhi II, and Parakrambahu made it bigger. There are two weirs, the 115-meter long large one across the Ambanganga and small one across Kudaganga. That was 29 meters long, to divert water in the Ambanganga for direct development of irrigation, and then went to Givitala, etc. So this is the map of these Anicuts. So here's the Abanganga, here's the Elena Canal. Elena Canal, this is Giritale, this is Minneri, this is Kaudulla, and this is Kanthalai. And this is the Jayaganga, also known as Yodha Kalava. These are the Knuckles Mountains. So the water comes down from the mountains to Kalava. And the Kalava get fed from a Miriskoni River. I could not find that in Google Maps. So it's either they don't have that anymore, that canal, or it's too small to be seen in Google Maps. I don't know. I didn't see the canal that coming from. Because Mahavansa says, it's Mahavansa or somewhere, says that they built a canal from Miriskoni River to Kalava to feed more water. And then Jayaganga, we saw the Jayaganga in going out, and it goes to these three reservoirs in Anuradhapura: Basavakkulama, Tisavawa, and Nuwarawawa. These three are in Anuradhapura town. Basavakkulama is Abhayawawa, built by King Pandukabhe. Tisavawa was built by King Devanampiyathissa, and this is the oldest one. And then this one, and the Nuwarawawa was built by King Valagambahu, and Kalava was added by King Dhatusena, because there were a lot of people living in Anuradhapura. There were a lot of people, and they were using this water, and they dry out. So they had to find a solution, and the solution was to build a huge reservoir here, closer to the mountains, capture all that water, and then build a canal. Build a canal here. And this is the problem is the elevation drop is very low here. So they have to go 6 inches drop per mile, which is very difficult to accomplish. And the other one is, this is the Yodha Wewa in Mana area. This is Mana. And this is the Malwahu area. And they put a Anicut, the one that we saw. You know, this Anicut here. Not this one, that's not that one. This one. This one. This is in Malwahu. So that one is here somewhere, and then they took the water here. So the question can be asked, Malwahu goes much closer to Yodha here. Why they didn't bring water from here to here? Why this is like 9 miles or something. You know, 9 miles of excavation with people, that's a lot of work. Why didn't they do it like that? So I don't know. I don't know. You have to look at the contours. You have to see why they didn't do like that way. Now, as you could see, Malwahu is flowing this way to the ocean. So this is high ground here. This is low ground. So probably from here to here, it's low ground to low ground. But here it's high ground, so you could use the force here and get the water here. Now if you from here to here, then what would happen is, see, the water flows from high head to low head, and if this is low, then this head here has to be low also, lower than here, otherwise the water won't flow. So if the head here is lower, then you reduce the capacity. And Jayaganga Yodha, we have, as mentioned earlier, the Jayaganga was built to bring water from Kalava to the 3 city reservoirs, and it's approximately 54 miles in length and 40 feet in width. 40 feet in width. Now the biggest question is, how did they maintain this 6 inches per mile? That is 1 in 10,000. It's very difficult task to do. That was something that considered to be very difficult to achieve. So there was another engineer named Mr. Belfer, a British engineer, imparts a striking example. When in charge of these works some years ago, I set out a new sluice on the Jayaganga, fixing its position according to modern ideas. And later on, when excavating for the foundation, we came across the ruins of an old sluice, thus showing that the engineer of some 1500 years ago had the very same ideas. So why do we need a sluice in a canal? Well, let me go back to our here. So what he's saying, you put sluice gate along the canal, and not only sluice, you put spills too, PITAWANA. So you put a sluice and take water out and give it to the paddy fields here. So when you're putting a sluice, you gotta make sure that elevation of the paddy field, elevation of the canal. If the paddy fields are higher elevation, then it's not gonna work. So it has to be lower. And you gotta find locations that you can put the sluice where there's less energy. Some place where it's meandering and wider, so the velocity is lower, so you're reducing erosion. So there's a lot of things to think about, and once you consider all that and you fix the location for the sluice, and then they go to construct it, there's the old sluice right there. And the engineer who did that long time ago, 1500 years ago, had the same ideas. That's what Mr. Bedford was saying there. So that's an interesting statement. And now we go to Elena Canal here. So Elena Canal was started by King Vasabha. Anicut was built at Ambanganga, and water was sent to Minneri, Kaudulla and Kanthalai. Later Parakrama Samudra also was added. So, and British Governor Henry Ward calculated the cost to build the first 24 miles of the Elena Canal to be 200,000 British pounds in 1857, based on labour and material rate existing at that time. So, to conduct the water of the Ambanganga to Minneri and to divert the streams falling from this range of hills, this wonderful embankment which extended without intermission for 24 miles was constructed. Its height, as before mentioned, varies from 40 to 90 feet, but taking its average at 50 feet, it must have contained more than 3,800,000 cubic yards of earthwork, which with the masonry would have cost at the present rate of labor not less than 200,000 British pounds, and that was in 1857. So let us stop here, and I want to keep these videos not too long. So let's join again for part 1B. Let's call it part 1B. Please join. Thank you.